So this is another trig substitution one. So with any luck, you memorize those trig substitutions that I asked you guys to sort of know. So which substitution are we going to use for this one? We've got the x squared plus a squared, which means we're going to use a tangent theta. Exactly. So in that case, since a is equal to 2, we'll do the substitution that x, sorry, bad start, I'm trying to write, that x is equal to 2 tangent theta. So if x is 2 tangent theta, what's dx? That'd be the derivative of that, which is 2 secant squared theta d theta. And then we'll just go in and we'll replace everything. So this becomes an integral of dx in the numerator, so 2 secant squared theta d theta divided by x squared, which should be 4 tangent squared theta, times the square root of 4 tangent squared theta plus 4. Everybody good with that? No issues there? Okay. So then we'll just simplify as much as we can. So first off, in the denominator here, this 4 tangent squared theta plus 4, we can pull a 4 out of that, right? And as we pull a 4 out of the square root, it becomes a 2 out there. And then that 2 will cancel with this 2. So the constant that we've got left is a 1/4. So let's just put that out in front of the integral just so we don't have to deal with it at the moment. Got 1/4 of an integral of secant squared theta d theta over tangent squared theta. And then if we took the 4 out of here, we would just be left with tangent squared theta plus 1 inside of there. And tangent squared theta plus 1 is secant squared theta. And secant squared theta's square root is just secant theta. Everybody good with the simplification of what's inside the square root there? To eliminate that root. Yeah, so Darius, we pulled out, first off, we pulled out the 4. Right here. In fact, I'll write the steps over here off to the side. So just for this piece, we pulled the 4 out, which made it a 2 root tangent squared theta plus 1, which is 2 root secant squared theta. And then the 2 we already canceled with the other 2. And so the square root of secant squared theta is just secant theta. Good on that? Okay. All right, so first off, we can cancel a secant in both the numerator and the denominator. So we should just have 1/4 the integral of secant theta d theta over tangent squared theta. And what can we do with that? How can we simplify that? What can we simplify secant theta over tangent squared theta to? Secant theta is what? 1 over cosine theta. And tangent squared is sine squared over cosine squared. So what can we do? Should become cosine theta over sine squared theta. And how can we integrate that one? All right, yep. So Adrian, you're right. We're going to let u equal sine theta. And so du will be cosine theta d theta, which we have in our numerator. So this becomes 1/4 of the integral of u to the negative 2 du. And the integral of that will go up to -1, right? And then divide by negative. So we end up with negative, and I'll just pull the constant back in, -1/4u plus our constant, or -1/4 sine theta. Right? Or we could just write that as -1/4 cosecant theta plus our constant. Everybody good with that? Here's theta. And we originally had x/2 was tangent theta. So tangent theta was x/2, opposite over adjacent, which makes this side that root x² plus 4. And we can then figure out what cosecant theta is. Cosecant theta should be hypotenuse divided by opposite. So we end up with -1. Well, actually, we do the 1. We end up with negative root x² plus 4 over 4 times x plus our constant. Everybody okay with that or no? Okay, I'm waiting. Yeah, so Nick, the green stuff, I just made a triangle using my original x equals 2 tangent theta. So if I divide by 2, that tells me that tangent theta equals x/2. So I drew a right triangle where the tangent of theta was the opposite over the adjacent, x/2. Then using the Pythagorean theorem, we can get the hypotenuse, which is root x² plus 4. It always ends up being that same thing that you had inside the square root. And then we said, well, what's the cosecant of theta? Since that's what we had here in our integral. Cosecant is hypotenuse divided by opposite, so that'd be root x² plus 4 over x. And then we multiply it by the -1/4. Good or no? Okay, don't worry, we're gonna keep doing these. So all right, how are we gonna go about this one? How are we gonna do this one? Yeah, we can definitely do that. We could let x equal 2 tangent theta. If we want to waste our time, we could do that. Thank you, Alex. Good. Yeah, it looks like a regular U sub, doesn't it? So don't get all caught up in seeing that term in there and saying you have to do this trig substitution. If I let u equal x² plus 4, then du is 2x dx. Put in a 2, put in a 1/2, and you got 1/2 the integral of u to the -1/2 du. And that's much easier. Right? And the 1/2 was inside of there. When we go up to a half and divide by half, that half cancels. So this just becomes u to the 1/2 plus a constant, or root x squared plus 4 plus a constant. So don't get all caught up in seeing that root x squared plus 4 term or something like that and saying, oh, it's definitely going to be this inverse trig substitution. Doesn't have to be. But just for fun, let's do it that way and see if it works out. See if it comes out to be the same thing. Should. So let's take a look. So if we were trying to do it the other way, we'd let x equals 2 tangent theta, is what you guys are saying, right? Which would mean that dx is 2 secant squared theta d theta. And this would become an integral of x, so 2 tangent theta in the numerator, times dx, which would be 2 secant squared theta d theta in the numerator, divided by the square root of x, it's not x, we're replacing our x's, 4 tangent squared theta plus 4. Everybody good with that? Okay, we're going to try and do a little bit more of the simplification in our head this time. If we take the 4 out of this square root in the denominator, what does it become when you pull it out of the square root? Should be a 2, exactly. So we pull that 2 out, and we have a 2 to cancel it. We still have a constant of 2. So we'll put a 2 outside of our integral. And then we're going to have tangent theta, secant squared theta, d theta, over, and then bottom, that's the square root of tangent squared plus 1. Tangent squared plus 1 is secant squared, and its square root is secant. Same thing we just had a minute ago. And so what do we end up with? We end up with 2 times the integral of secant theta, tangent theta, d theta, which is just what? Should just be 2 secant theta plus a constant. And we'll draw our triangle. There's theta, there's our right angle. Tangent of theta was x over 2, which made this root x squared plus 4, same triangle we had before. And secant then ought to be our hypotenuse divided by our adjacent. So this becomes 2 root x squared plus 4 over 2 plus our constant, or just root x squared plus 4 plus the constant, which is exactly what we got doing it the easier way. It'll still work out. It's just a lot more work if you do it this way. So always look and see if there's a simple u substitution that you can use first. If there's not, then go ahead and do this inverse trig sub. Any questions, any issues with that? No? All right. Let's take a look at this one. 1 over the square root of x squared minus a squared dx. How are we going to go about integrating this one? Do you see a simple u substitution this time? Answer should be no there, right? And there's no simple u sub, so we're going to have to use one of these inverse trig substitutions. So when it's x squared minus a squared, what's the substitution we need to use? We want to let x equal what? A secant theta, yep. All right, and so then that tells us that dx is equal to a secant theta tangent theta. Everybody agree with that? And our integral becomes an integral of a secant theta tangent theta d theta, forgot the d theta on there, divided by the square root of x squared, which is a squared secant squared theta, minus a squared. And what can I do with that? What can I pull out of the denominator, that square root in the denominator? I can pull the a squared out, which just becomes what? Just becomes an a, good, which will cancel with the a in the numerator. Leaves us with secant squared theta minus 1 inside the square root. What's secant squared theta minus 1? Secant squared theta minus 1 ought to be tangent squared theta. And what's the square root of tangent squared theta? Tangent theta, which should cancel with the tangent theta. So what are we really just left with here? It's an integral of secant theta d theta. Good or no? Everybody all right with that simplification? Okay, what's the integral of secant theta? D theta. That's what I told you should memorize, right? Natural log, absolute value, secant theta plus tangent theta, plus a constant. And then what are we going to need to do? We're going to have to convert those thetas back into x's. So there's theta, there's our right angle. And we had originally that secant theta, which is hypotenuse over adjacent, was x over a. And that gives us this side as square root x squared minus a squared. Good or no? So natural log absolute value secant theta. So secant theta we knew was just x over a, right? And then plus tangent theta. And tangent theta ought to be opposite over adjacent, which is root x squared minus a squared over a plus a constant, which is an okay answer. But how can we make this answer better? By using log rules. Oh, wait, no, I said that. This becomes natural log absolute value of x plus root x squared minus a squared minus what? The natural log of the absolute value of a plus a constant. What's the natural log of a? That's a what's natural log of a? It's constant. So if I have minus a constant plus some other constant, that's just like adding some constant. So we could say this equals natural log absolute value x plus root x squared minus a squared plus some constant. Good or no? All right. Let's see if we can do something fun with this. So let's see if we can find the area of an ellipse that we get from the equation x squared over a squared plus y squared over b squared equals 1. So the area of this ellipse. Basically, we're going to see if we can derive the formula for the area of any ellipse. So what does this ellipse look like? We should know basically what this ellipse looks like, right? Should be centered at the origin, and it should go out A units, and it should go up B units, right? How are we going to find that area? The area just should be the area underneath the curve, shouldn't it? Yeah, we could find the integral from -a to a and then multiply it by 2, or we could find the integral from 0 to a and multiply it by 4. I think that's going to make life even a little bit easier if we just do 0 to a. So let's do that. But first, we have to have a function to integrate, right? So we're going to put this in terms of y. What does y equal? It ought to be 1 minus x squared over a squared times b squared, all inside of a square root. If we solve that for y. Everybody agree with that? And so we want to find just this piece of it, and then we're going to multiply it by 4, right? So what can I pull out of that equation that's a constant for my integral here? We're going to do 4 integrals, right? And we can put a b out in front because we have a square root of b squared, which can be pulled out here. So we're going to have 4b times an integral from 0 to a of the square root of 1 minus x squared over a squared. Everybody good with that so far? Can I rewrite what's inside of that to make it look a little nicer? Could I get a common denominator? If I get a common denominator of a squared, this will be a squared over a squared. So I'll have a squared minus x squared over a squared. And what can I do with that over a squared? It should be able to be pulled out as a what? As a 1 over a, right? So we're going to have 4b over a times an integral from 0 to a of root a squared minus x squared. I forgot my dx's here, dx. Good or no? And then what should we be able to do with this? Which trig substitution should we use? We'll let x equal what? A sine theta, and dx will be a cosine theta d theta. And so this ought to become 4b over a times an integral of, and we'll have root a squared minus a squared sine squared theta. Times dx, which was a cosine theta d theta. And then we've also got to change our limits of integration because we've done a substitution. So our x value was 0 to start with, right? So if I say 0 is equal to a sine theta, what is the theta value now that these need to be thetas? Theta ought to be still 0. Okay. And if we have a equals a sine theta, then what should theta be? Sine theta equals 1, theta ought to be pi over 2. Everybody good there? Okay, now we're going to need to simplify. So let's see. What can we do? We can take this a that's a constant out, right? And pull it out here. That's going to cancel with the a that's in the denominator. And then we can also pull an a out of here, can't we? An a squared times 1 minus sine squared, which comes out of the square root as an a. So we're really pulling an a times an a out of here, which will cancel with this a, and we'll end up with what constant out in front. What should our constant be out in front? Yep, 4ab. Yep, we're pulling an a out of the square root, and we're pulling an a from here. So effectively putting an a squared, which cancels and gives us 4ab. And then if we pull the a squared out of the square root, we're left with 1 minus sine squared, which is cosine squared. And when we square root that, that's just cosine, times the other cosine gives us cosine squared. So this integral should turn into 4ab times the integral from 0 to pi over 2 of just cosine squared theta d theta. Good or no? It is not cubed, Adrian. It's squared. I have 1 minus sine squared, which is cosine squared, but it's inside of a square root. So that just becomes cosine times the other cosine is cosine squared. Okay, so how do we deal with the integral of cosine squared theta? We need to use the power reducing formula. Power reducing formula says 1/2 of 1 plus cosine 2 theta. So half of this is just a 2ab out in front. We can cancel those out. Still an integral from 0 to pi over 2. Now it's 1 plus cosine 2 theta d theta. And that ought to give us 2ab times integral of 1 is theta, integral of cosine 2 theta is 1/2 sine 2 theta. And we're going to integrate that from 0 to pi over 2. Any questions on that so far? Then we'll just plug it in and be done. So we got 2ab times pi over 2 plus 1/2 the sine of pi minus 0 plus 1/2 the sine of 0. And what's the sine of pi? Sine of pi is 0. That's 0. 0 is 0. Sine of 0 is 0. So all three of those terms just go away. And we end up with pi a b. And this is units squared if we want to attach that in there. Pi a b units squared should be the area of any ellipse. Any questions or issues with that? Now you know the formula for the area of any ellipse. It is. It's fun and exciting. You're right, Darius. Used a lot of good stuff in there. Power reducing formula, inverse trig substitutions. Good times. And since this one was, yeah, so I was just going to say that, Nick. We don't have to do anything with the triangle to turn it back in terms of x, unless you really want to. But since this is a definite integral, remember, whenever we do substitutions with the definite integral, as long as we remember to change our limits of integration, we don't have to switch back to the original variable to evaluate them. We can evaluate them in the new variable. So this time we don't have to go back. We could have, had we gone back, we got the exact same thing. But Probably nicer not to have to. Any other questions on that one before we move on to something else? I mean, not something entirely new, but just another problem. Another definite integral here. Okay, so the integral from 0 to 3 root 3 over 2 x cubed over 4x squared plus 9 to the 3/2 power. So what are we going to do with this? U sub, as if you want to let u equal 4x squared plus 9, and then have an 8x, and have to turn that x cubed into something. I think that's going to be unpleasant to do a u sub. I think we're going to want to use our inverse trig sub here. So what's the inverse trig sub we want to use? We've got 4x squared plus 9, right? What do we think will work out there? This is like having 2x squared plus 3 squared, isn't it? Isn't that what 4x squared plus 9 is? So rather than having an x squared, right, plus the a squared, it's like a 2x squared plus the a squared. So rather than having x equal a tangent theta, let's let 2x equal a tangent theta. So it's kind of like a u substitution there, except we're not really writing it out, Adrian, to get our inverse trig sub. Good or no? So first off, what are we going to have in our denominator? 4x squared plus 9. Well, our 4x squared is 9 tangent squared theta. So that'll be 9 tangent squared theta plus 9 to the 3/2 power. And what about our numerator? Our numerator, which is x cubed. Well, what is x equal? X is 3/2 tangent theta. So if we're going to replace the x cubed, that ought to become 27/8 that gets pulled out times our tangent theta. Sorry, tangent cubed theta. And then we need a dx, so our dx is another 3/2 secant squared theta d theta. So this is going to get a secant squared theta and a d theta. And we're also going to need to multiply this by 3/2. Everybody good with that? Or no? Okay, so what do our limits of integration need to become? These were x values, so if x is 0, we end up with 0 equals 3/2 tangent theta. And what does that tell us theta is equal to? Should be 0. And if we had a 3 root 3 over 2, 3 root 3 over 2 equals 3/2 tangent theta. What does that tell us? that tangent theta equals √3. And what is tangent equal to? Or sorry, what is theta equal to? Yeah, pi/3. All right. So everybody good with all of the conversion from x to theta? Okay. So we still have some constants in the denominator to deal with. So let's deal with the constants in the denominator. 9 tangent squared theta plus 9, we can factor a 9 out of that, right? So we have 9 factored out. As it comes out of the parentheses, it first gets square rooted, which makes it a 3. Then it gets cubed, which makes it a 27. So we have a 1/27th, which will cancel with the 27 up there. So our final fraction out in front just becomes 3/16. And then it's an integral from 0 to pi over 3. And this is tangent squared theta plus 1, which is secant squared theta. We square root secant squared theta, which makes it secant theta. But then we cube it, which makes it secant cubed. And so we have a secant cubed in the denominator and a secant squared in the numerator, which makes it just a secant in the denominator. So we got tangent cubed theta d theta over secant theta. Everybody good with that simplification? Okay. And what do we simplify tangent cubed theta over secant theta into? We put it into sines and cosines, what does that become? That's sine cubed over cosine cubed divided by 1 over cosine, which ought to be a sine cubed over cosine squared. Good, Nick. So this is sine cubed theta over cosine squared theta d theta. All right, and how are we going to go about integrating that? That one's a pretty straightforward integral. What u substitution can we make? Yeah, if we let u equal cosine theta, then du will be negative sine theta d theta. So first off, let's put our negative outside and put our negative inside. And I'm going to want to have as many cosines in there as I can, because I just need a negative sine theta d theta. So I was still left with a sine squared theta up there. Well, sine squared theta is 1 minus cosine squared theta, isn't it? So now that's going to allow me to turn this into 1 minus u squared du over u squared, which should be one that we can deal with pretty easily. But before we can do that, what do we need to do with the limits of our integration? Since we've now gone into terms of u rather than theta or x, we got to go back and fix that. So if the denominator was, or not the denominator, but the lower limit was 0, cosine of 0 equals 1. So that lower limit needs to be 1. And then the upper limit was what? It's pi over 3, I think. So the cosine of pi over 3 is 1/2. So now this becomes an integral from 1 to 1/2 of negative 3/16 of this. Sorry, I shouldn't have written those in there yet because we didn't actually convert that into u's yet. So we'll leave those as zeros and pi over 3 until we convert it right now. So let's do the conversion into u. So this becomes negative 3/16. Now it's 1 to 1/2. And then this becomes 1 minus u squared du over u squared. Everybody okay with that now? Sorry about that. Got ahead of myself a bit. Okay. And then I have a negative outside, and my lower limit is larger than my upper limit. So maybe I could flip those and get rid of the negative. So let's just make that 3/16 of the integral from 1/2 to 1 of this. And how am I going to integrate 1 minus u squared over u squared? Yeah, we can separate it if we want. 1 over u squared, right? That's u to the -2 minus 1. I mean, we don't have to write it as two different ones, but if you want to, 1 over u squared minus u squared over u squared. And what does that integral become? The integral of u to the -2 is what? Should just be -1 over u. And then the integral of -1 should just be minus u. And we'll do that from 1/2 to 1. Which gives us what? 3/16 of, so plug in the 1, that's -1, -1, minus, and then plug in the 1/2, that's -1 over 1/2, which is -2, and then minus 1/2. And what does that all simplify out? Again, -1 minus 1 is -2, plus 2 cancels out, and then plus 1/2. So we got 1/2 of 3/16, which is 3/32. That's a fun one, huh? Yeah, also fun and exciting. That's right, Darius. The good news about this is they only keep getting more difficult than this. That's good news, right? I think that's good news. Any issues, any problems with that one? All right, let's take a look at this one, which we should be able to do in a very similar manner. Any thoughts on that? What are we going to do with it? Can I turn that denominator into something that I can use one of these trig substitutions with? Can I turn it into, okay, yeah, so factoring it, I mean, what does it factor to? Does it even factor? I guess it does, right? It does factor to x. Negative x plus 3 times x minus 1. But no, that's not going to help us. We don't want to, I mean, we do sort of want to factor it, but not exactly. We want it to look something like a squared minus x squared, or a squared minus like some u squared. Yeah, Alice, that's exactly right. We're going to complete the square with it. So let's do that. First off, it might be helpful if we just took the negative sign out of it. And we'll deal with that in a minute. So x squared plus 2x minus 3. And then within there, if we want to complete the square, we need to have this be an x squared plus 2x plus a 1, right? That's what completes the square. So if I add a 1 into there, I also have to subtract a 1. So that'd make a minus 4 there. Everybody good with that? Try to give us the opposite of x plus 1 squared minus 4, or minus 2 squared. Or if I pull that negative sign back in there, that ought to be 4. We'll write as 2 squared. 2 squared minus x plus 1 squared. And so what does that look like? that looks like a squared minus u squared, right? Where u is equal to x plus 1. And so we can make a substitution where x plus 1, our u value there, is equal to 2 sine theta. And we're choosing sine theta because it's like a squared minus u squared. Everybody good with that? And what does dx equal? Dx ought to be 2 cosine theta d theta. So since we know that this denominator down here, 3 minus 2x minus x squared, is the same as 2 squared minus x plus 1 squared, what can we turn that into? Should be able to make this an integral of x in the numerator, so 2 sine theta minus 1 times our dx, which is 2 cosine theta d theta, divided by this 3 minus 2x minus x squared, which ought to just be a square root of 4, or a 2 squared, minus our x plus 1, which is 2 sine theta squared, or 4 sine squared theta. Everybody good with that so far? Everybody okay with that or no? Yeah, that's a 4 before the sine squared, right? Yeah. So if I factor the 4 out of that, it becomes a 2, right? When I pull it out of the square root. And this is a 1 minus sine squared, which becomes a cosine squared. And the square root of the cosine squared becomes cosine. So this really just becomes 2 cosine theta in the denominator, which will cancel with the 2 cosine theta in the numerator, making this an integral of 2 sine theta minus 1 d theta. Everybody good with simplifying that? And then we'll just integrate it. Our integral then should become negative 2 cosine theta, and then minus the 1 becomes minus theta, plus our constant. And what do we have to do with that? We have to replace the thetas. So if we go back and draw our right triangle, there's our theta, there's our right angle, and we knew originally that x plus 1 was 2 sine theta, so sine theta was x plus 1 over 2. So that's x plus 1, and we have a 2 over our hypotenuse. And this becomes that same 3 minus 2x minus x squared that we started with inside the square root. Everybody good or no? All right, and so negative 2 cosine theta, cosine ought to be our adjacent over our hypotenuse. So the 2's will cancel. So we end up with negative root 3 minus 2x minus x squared minus our theta. And theta ought to just be, if x plus 1 was equal to 2 sine theta, theta ought to just be the inverse sine of x plus 1 over 2. That'll be minus the inverse sine of x plus 1 over 2 plus our constant. Any questions on that? Everybody okay with that? Sure, Duffy. Go back a page. You guys can see that they get a little more complicated once you get some, more unpleasant stuff in the denominators there inside the square roots. Yep, no problem. Everybody else good with that? All right. You guys want to try and do one on your own? This one's pretty similar to the last one. I think you should. All right. I'll give you guys about 5 minutes to see if you can get this one taken care of on your own. Ready, go. So, first off, if we complete the square with this thing inside the square root, what does it look like? It looks like the integral of 1 over the square root of x plus 4 squared, right? That's x squared plus 8x plus 16. And we still have 9 more left. So x plus 4 squared plus 9 dx. Hopefully you're all good with that first step. Then the substitution we'll do is we'll let x plus 4 equal 3 tangent theta. Since this is a u squared plus 3 squared, we'll make it 3 tangent theta. And then dx is equal to 3 secant squared theta d theta. Good or no? So our dx becomes 3 secant squared theta d theta in the numerator, and then in our denominator, we'll end up with 9 tangent squared theta plus 9 inside of that square root. Or 9 plus 9 tangent squared theta. I don't know why I wrote it backwards, but I did. And what do we end up with then? We'll pull the 9 out, cancels with the 3. We got no constant left. We have a secant squared in the numerator, and the 1 plus tangent squared becomes a secant squared, which we squared to become a secant. So we literally just end up with an integral of secant theta d theta. Is that what you all got for your integral? Good. Which should be natural log absolute value secant theta plus tangent theta plus your constant. All good or no? And then we'll draw our triangle. There's our theta. And we originally had x plus 4 equals 3 tangent theta. So tangent theta was x plus 4 over 3. And as always, that comes out to be that same thing that we originally had inside of our square root. Root x squared plus 8x plus 25. And this ends up becoming the natural log of the absolute value of secant theta. So secant theta is root x squared plus 8x plus 25. Over the 3 plus the x plus 4 over 3 plus our constant, and then that 3 in the denominator can become just a natural log of 3, a minus natural log of 3, which is part of the constant. So our final result in a nice simplified form would be natural log absolute value x squared plus 8x plus 25 plus x plus 4 plus our constant. Everybody good with that? Is that what y'all got? You might have had it with the over 3s. If you left it with the over 3, that's fine. It's just not as simplified as it could possibly be. But that's okay.